Inverse functions, function 5. A function f has an inverse if and only if f is bijective. If f is a bijective function, f inverse results when the domain and range elements are interchanged. In other words, if you have a bijective function and you interchange the domain and the range elements, what results is the inverse function. So relationship between a function and its inverse. The domain of f is the range of f inverse, and the range of f is the domain of f inverse. Remember, you interchange the domain and the range element. You interchange, they switch around. Range becomes domain and domain becomes range. The graph of f inverse can be derived from the graph of f by reflecting f in the line y is equal to x. Whenever you reflect in the line y is equal to x, you interchange the x and y value. All right, which is the same thing you do when you're finding the inverse of a function. So reflecting the graph of a function, if you reflect the graph of a function in the line y is equal to x, the graph that results would be the inverse, function. Example 16. It says, example 16 says, find the inverse of the function shown in the diagram. So this is a function, and we want to find its inverse. Remember, to find the inverse, if you have a bijective function, to find the inverse, you simply interchange the x and the y values. You interchange the domain and the range. So putting back domain, range, 1, 2, 3, 4. So the range elements 1, 2, 3, 4 now becomes the domain elements. All right, so the A, B, C, D, the domain elements now becomes the range elements. All right, let's get the mapping. 1 maps to A, 2 maps to C, 3 maps to B, 4 maps to D. So if we have the function on the left, what we have on the right is the inverse function. All right. Example 17. Find the inverse of this function here. So here we have a function represented as a set of ordered pairs. Um, the domain elements are the first elements and the range elements are the second element. By simply interchanging the domain and the range elements, what we'll get is the inverse. So the inverse function, all right, would be 5, 1, 10, 2, 15, 3, 20, 4, 25, 5. So if up top we have the function, below would be its inverse. So far, a function represented as an arrow diagram or a set of ordered pairs, all I have to do to obtain inverse is to interchange the x and the y values, to interchange the domain and the range values. All right, example 15. It says a function f is defined by f of x is equal to 4x plus 2, where x are elements in a set of real numbers. Find in a similar form f inverse. All right, so here we have a function represented as a formula or as an equation that we need to represent as we need to find the inverse of. From CSEC, you have the 4-step method. Step 1, take out f of x and write y. So I have y is equal to 4x plus 2 So in step one, this is called the defining equation. So this is step one. We just write the defining equation. Step two, the most important step, interchange x and y. Wherever you see x, you put y. Wherever you see y, you put x. So we have x is equal to 4y plus 2. This is step two. Step three is to make y the subject. So that means I need to have y alone on one side. Positive 2 comes over and become negative 2. So I have x minus 2 is equal to 4y. Then I divide both sides by 4 because I need y alone on one side. So now what I have is y is equal to x minus 2 over 4. This is step 3. And step 4, the final step, is to write in function notation. So I'm going to take out back f, y, and say f inverse x is a function. So is x is mapped onto what? F inverse of x is equal to x minus 2 over 4. This is step 4, the 4-step method. All right, and we learn that from CSEC. Ensure that you rehearse it so that you remember it at all times. It says a function f is defined by f of x is equal to 2x plus 1 over x minus 3, and we're to find in similar form f inverse and state the value of x for which f inverse is not defined. All right, so let's go back a little. So this is what it's 2x plus 1 over x minus 3, and x is not equal to 3. So we have f of x is equal to 2x plus 1 over x minus 3, and x is not equal to 3. All right, so x is equal to 3 is the value of x for which this function is undefined. All right, so x is equal to 3 cannot be in the domain of the function. Let's find the inverse 4-step method. Step 1, take out f of x and put y. That's step 1. And all we're basically doing is we're writing the defining equation. Step 2, the most important step, we're going to interchange x and y. Wherever I see x, I'm going to put y. Wherever I see y, I'm going to put x. So this is x would be equal to 2y plus 1 over y minus 3. That's step 2. Step 3, I'm going to make y the subject. It means I need to have y alone on one side. Now, if I have one fraction is equal to one fraction, what I'm going to do is I'm going to cross multiply. So this is x times y minus 3 is equal to 1 times 2y plus 1, which is 2y plus 1. Whenever you're multiplying things by 1, it remains the same. I'm going to move the brackets over here by applying the distributive law, which says everything inside the bracket is multiplied by what is immediately outside the bracket. So x times y is xy minus x times 3, which is 3x, is equal to 2y plus 1. So I'm trying to make y the subject. I need to get all y's on one side. Anything that don't have in y goes to the other side. So I have xy, positive 2y comes over and become negative 2y, and negative 3x goes over and become positive 3x plus 1. Going after making y the subject. Here y is common, on the left y is common, so I'm going to factor out y. y into xy is x, y into 2y is 2, is equal to 3x plus 1. Divide both sides by x minus 2. X minus 2 cancels x minus 2. I have y alone on the left, is equal to 3x plus 1 over x minus 2. All right, that would be step 3. And step 3 says make y the subject again. And then the third step would be to say f inverse of x, the last step, would be equal to 3x plus 1 over x minus 2. All right, so these are steps that we learned from CSEC. Let's have a look at another question. Example 20. It says the function g is defined by g of x is equal to 3x minus 1 over x plus 2, where again x cannot be equal to minus 2, so x is the value of x. Oh, there was something else in this question we should have answered. The last part of the question says that we need to what? And state the value of y for which f inverse is not defined. All right. Now, this is a function f inverse of x. Now, this function is undefined whenever the denominator is equal to 0. So what we need to do is to find out which value of x is going to make the denominator 0. So to answer the question, the value of x for which the function is undefined, you're going to equate the denominator to 0. So x minus 2 is equal to 0. Therefore, x is equal to 2 is the value of x for which f inverse is undefined. All right. And all of this is simply saying if x is 2, this function is not a function anymore. Because when x is 2, there's no value for f inverse x. So for x is equal to 2, for domain element x is 2, there's no range element. And that is a no-no for a function. All right, in such a case, it would not be a function. So that value of x makes the function undefined. Example 20, it says a function g is defined by g of x is equal to 3x minus 1 over x plus 2, where x is not equal to minus 2. And the simple reason is that if x is minus 2, what you're going to have is that g of x, which would be the image, or g of 2, which would be the image, you will not be able to get g of 2. You will not be able to find any value g of 2. So because if x is g of minus 2, if x is minus 2, what you're going to have is that the denominator is going to be 0. And you're going to have 3x minus 1 divided by 0. And it's impossible to divide by 0. So there's no value, there's no image value g of minus 2. So therefore, x is equal to minus 2 cannot be in the what? Domain of g. All right, so that is why x is not equal to minus 2. So let us get an expression for g inverse of x. All right, so g of x is equal to 3x minus 1 over x plus 2. Remember your four-step method. Step 1, take out g of x and put y. Y is equal to 3x minus 1 over x plus 2. Step 2, interchange x and y. Wherever I see x, put y. Wherever I see y, put x. So x would be equal to, sorry, 3y minus 1 over y plus 2. This would be step 2, interchange x and y. Step 3 is to make y the subject again. I need to, when I'm finished, I must only have y alone, one y, and it must be on one side by itself. So if I have one fraction is equal to one fraction, I'm going to cross multiply. So we have 3y minus 1 is equal to x times y plus 2. Doesn't matter which side. Distributive law, we have 3y minus 1 is equal to xy plus 2x. I just apply distributive law. I need all my y's on one side and everything that don't have in y on the other side. So now I have 3y minus xy. Positive xy goes over and become negative. And now I have negative 1 goes over and become positive 1 plus 2x. Over on the left, y is common, so I'm going to factor out the y. Y into 3y is 3. Y into xy is x. And this is equal to 1 plus 2x. Divide both sides by 3 minus x. These cancel. So I end up with y is equal to 1 plus 2x divided by 3 minus x. And my final step, fourth and final step, is to say g inverse of x is equal to 1 plus 2x over 3 minus x. So the last part of the question, I think the last part of the question we're supposed to find g inverse of 3. Now, if I have g inverse of x, so this is the second part of the question, g inverse of x is equal to 1 plus 2x, and I have 3 minus x, and I'm asked to find g inverse of 3. All right. This is odd. Is something wrong? No. Positive? No, it doesn't seem so. Because it's not possible. Because it's not possible. G inverse of 3 doesn't exist. It's not possible. Because x cannot be equal to 3. Here, x is not equal to 3. So it's impossible to find g inverse of 3. Double checking to see if I did anything wrong. No, I don't think so. So therefore, g inverse of 3 has no value. Alright, just double checking my calculation on the left hand side. In cross multiply, fine, 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 fine. Alright, so we can't. Alright, so there's no value for g inverse of 3. Alright.